Today we're going to solve exponential equations. Tomorrow we'll do logarithmic equations. So today we're going to look at exponential equations that have exponents on both sides and when there's only exponents on one side. When there's exponents on both sides, it's actually a little bit easier. If we've got 5 raised to the stuff equals 5 raised to the other stuff. If the 5s are the same and these two equations are equal, that means the stuff has to be the same. So if the bases are the same, if you've got 5 to the blah equals 5 to the blah, those two exponents are going to be equal to each other. So I think these are the easiest type of exponential equations to solve because all you do is put the exponents equal to each other, and then this is the type of equation that we've been solving forever and ever. So we would subtract 3x on both sides. We would subtract 8 on both sides. X equals -5. Okay, number 2 in your notes, there is a typo. The -1 is supposed to be up in the exponent. So this should say e to the 3x equals e to the 2x minus 1. Just because this one is e instead of a number doesn't change anything. Are the e's the same on both sides? So the exponents have to be the same on both sides. 3x has to equal 2x minus 1. Are these the easiest equations we've ever solved? Pretty easy. So of course there's a catch, right? There's got to be a catch. What do you notice about number 3? They're not the same. So we need to think about how are 8 and 2, how could we compare 8 and 2 using exponents? And I will likely help you with this as much as I can. If you're not familiar with your perfect squares, perfect cubes, perfect fourths, which you may not be, you might need to have your perfects chart out. But 2 to the 3rd equals 8. So our hint here is that 2 to the 3rd is the same as 8. So I'm going to take 8 out of this equation and replace it with 2 to the 3rd. Now, there's still that x, and I put parentheses because sometimes it's like x plus something. If there's more than one thing in that exponent, you would just put it in parentheses. But that x still stays in the exponent. The 3 is just joining it in the exponent. So we took this 8 and replaced it with 2 to the 3rd. And by doing that, we now have 2 to the stuff equals 2 to the stuff. So 3 times x is going to be the same as 5x minus 2. We just had to do a little bit of tweaking to how the equation was written before we could set the exponents equal to each other. So now we have 3x equals 5x plus 2. I don't like having negative x's, but I will in this case. X equals -1. So why don't you try number 4 on your own using that hint. The most common mistake is replacing the wrong thing. A lot of people try to take this 3 on the right and make that 3 to the 3rd. you can't stick an exponent in someplace where it wasn't. You're taking the bigger number, the 27, and you're replacing that 27 with 3 to the third. So don't change the smaller one, you're replacing the bigger one. So you might want to make yourself a note, replace the bigger one. So 27 is 3 to the third times that 2x that's already in the parenthesis or in the exponent. That looks a little bit muddled. There we go. Equals 3 to the fifth. Then we can do 3 times 2x equals 5. 3 times 2x is simply 6x. This one's kind of an icky one, isn't it? X equals 5/6. So sometimes it's like this. 5 to the x minus 3 equals 25 to the x minus 5. Do you see how both exponents have more than one term in them? Which number would you replace? Would you replace the 5 or would you replace the 25? You'd replace the 25. 25 is the same as 5 squared. That x minus 5 would just need to go in parentheses because that 2 that you stuck in the exponent has to be multiplied to both of those. So that would be the first step of that problem. So in these next examples, we don't necessarily have exponents on both sides. Number 5 and number 6, we only have an exponent on one side. When you have an exponent on one side, we are going to isolate the exponent and then we are going to change forms. We're going to change it back into log form. So remember the log ride? Woo! We're going to do that. So first thing we need to do is make sure that this 2 to the x is by itself. So if there was anything added or subtracted after it or multiplied in front of it, we need to get rid of that first. Once the exponent is isolated, we need to change forms. So this is exponential form. We need to go woo and change it to log form. So log base 2 of 7 equals x. If only we knew how to calculate log base 2 of 7. Oh wait, we do. So using your calculator, you can use the change of base. This is why I've had you practicing that change of base. You do log button 7 divided by log button 2. And log button 7 divided by log button 2. Make sure you close your parentheses each time. It's probably going to be a crazy decimal. 2.807 equals x. In number 6, the thing that we are raising to the exponent is the e. So we want to get that e by itself. How do we get rid of the 4 that's in front of the e? Divide. So we have e to the 3x equals 3. I like to think of this as any time that you feel stuck, change forms. So we have this exponent thing by itself. We can't actually do e to the 3x. The only way to get x out of the exponent is to take the log, to change it to log form. So start with that e and woo! Log base e of 3 equals 3x. Okay, hold on a second. Log base e. Anyone remember what log base e is? ln. This is ln of 3 equals 3x, which actually makes this a whole lot easier to calculate. You don't have to do the change of base formula. You just punch the ln button in your calculator, the 3. We get 1.099 if we round. How do we finish solving this one? Divide by 3. So I believe the answer you should get is 0.366. Yeah. Okay, we're skipping number 7. Be brave. Try number 8 on your own. Pause the video. Try number 8 on your own. Your first step is to get 5 to the x by itself, so we need to subtract 7 on both sides. Then we're stuck. X is in the exponent. We need to change forms. So, log base 5 of 19 equals x. To evaluate this, we use change of base. Log button 19 divided by log button 5. Log button 19, close my parentheses, divided by log button 5, close my parentheses. I get x equals 1.829. It doesn't say how far to round, but typically 3 places after the decimal is a good amount with logarithms. On your assignment is worksheet 5. You may need, in case you don't know, 5 squared is 25, 6 squared is 36. Those would be your hints for 2 of the problems. The rest should be pretty self-explanatory.